First of all, water is this rather unusual molecule. It's oxygen with 2 hydrogen, but the hydrogen are offset, giving it a slight polarity or charge. So it has a charge of a little bit positive in one direction, a little bit negative in the other direction. And that means that it can line up to electrical and magnetic signals. It can also respond in lining up to other water molecules when it's in different forms. So that makes it unique, and here's 6 reasons why it's unique. First, water is a liquid at room temperature, very convenient for us, but other hydrogen compounds don't tend to be a liquid at room temperature, so that's a unique property. Another one that we're all familiar with is that ice floats on water. So the solid ice, the solid form, floats on liquid water and is less dense. And that's because these molecules tend to line up and form a crystal structure that actually takes up more space when they're in a solid form than a liquid. The third very important thing is water has a very high heat capacity, about 10 times that of copper or iron, so it can really moderate temperatures, especially the Earth's climate. So it can store a lot of heat as it moves around. Water also has a relatively high heat of vaporization. That means it takes a lot of energy to move it from a liquid form to a vapor form. This is important because that high heat of vaporization moves a lot of energy as water evaporates. We see this when we feel like when we go swimming and when we get out of the pool, we can feel the water evaporating from our skin and it feels cold. That's the latent heat of vaporization in action. The fifth thing is it's an excellent solvent. Almost everything dissolves in water, and that's what some of these pictures are showing you, different complex molecules, salt molecules and whatnot, chlorine, being able to dissolve in water. And that's also because these slight positive and negative charges, the dipole of the water molecule, can really grab onto other molecules. And the final thing is surface tension and capillary action. So water really does suck. What it does is if you put a napkin into a glass of water, water will actually get drawn up into that. It'll come up above the level of water. And that's because of this, again, the dipole and the ability of the water to actually go up into the napkin. It does the same thing in soils, which is very important because otherwise all of our soils would be completely dry if the water just drained out. The water actually, the soil holds some of that water, which is important for us.